What does it say?
Inches.
Wow. Holy crap. That's another thing we'd say. That's a big, Mamma Mia, that's a big part. Isn't it? Huh? Wow. Dimensions are in inches and unspecified tolerances. Okay. How much does that thing weigh? Oh my God. 60 inches wide, 111 inches long, 5 foot wide block of steel. I don't know about that. You know, I think that's a mistake. I kind of do. All right. What else do we know about if it's a metric and it's following, it says it's following Y 14.5, 2009. So what else do we know about metric and inch? What's the differences of the fractions or the decimals?
On the inch, you don't have a leading zero.
Ah, but on metrics,
You do.
you do. All right, what about the trailing zero? Trailing zeros, inch and metric. What do we do with them? Keep them on inch or lose them? Okay. Normally, we keep the zero, okay, on the front end if it's what? Inch or metric? Metric. Okay. So it's just the opposite. And then we chop the zero off. We don't have a placeholder zero as a rule. It's supposed to follow it. Okay. If it's metric. No trailing zeros. No placeholders. Okay. Let's look around on here. Ah, there's one there. Okay. But now this is a tolerance. I think that's allowed for that. Okay. But just dimension by itself, no. Say if it's true metric, it would be 1.6. Okay, so here's an inch drawing. So we're looking at that. Okay, so no leading zero, but we got trailing zeros. So, is it inch or metric? It looks like it's metric. I'm just going to say it's a metric drawing. They made a mistake. Okay? All right. I decree it. All right. Then B is positional tolerance at the possible produced sizes for that dimension. So let's see. It's a hole. So at 12.65 it'll be 0 position tolerance. Then as we move away from there, increase, then we're allowed to add. Okay. Then datum D. All right, let's look for datum D. I think I have this stuff memorized.
Top view.
Top view.
Top side.
There it is. All right, so it's the total width, which is a very odd number too, 60.32. Okay, so it's 60.32. All right, so since it's placed on a kind of a rectangular or standard kind of, you know, it's not on a diameter, then it's basically a center plane. So it's a datum D is a center plane. Okay, I'm going to need to. All right. Look. looking at the 44.45 dimension. Picking this thing apart up here. It's a 0.12 position tolerance zone. Okay, and references datum D, regardless of feature size. Oop, right here. All right, and the meaning of the information is basically reading it. It's a center plane relationship since this measurement is referencing D. D is a center plane datum, so it's got to be, this measurement has to be on center with this one. So true position exists when the center plane of the feature and the datum center line, center plane line up. Okay, so when the two, this feature center and lines up with this, then it's at true position. Okay, and it's allowed to fluctuate within a 12 hundredths, I said 12,000, 12 hundredths tolerance zone. That's two parallel planes. Okay, and then that applies at MMC. So when this part, dimension, this feature, is at MMC. So it'd be, now it's an external feature, it's not a hole, it's not a diameter, but it is, let's see, an external feature. We still consider that, you know, so at MMC, max material condition, would be when this is at its largest. I know it's a slot, kind of like a hole, but it's not really a diameter. Okay, so
You're referring to the wrong one.
I was?
Yeah.
Well, anyway, 445 is, that's what I meant. If we were looking at this one, no.
Correct.
All right, 441, let's move on. Start moving faster, I promise. I'm going to change what I'm doing here, too. Rear. What? Oh, it's upside down. That's freaky, isn't it?
You put out of these sleep, yeah, that's a good way.
Watch this. What? Yeah. I don't know why it does that. Usually at the high resolution, it's the worst. Okay. All right, so we're looking at this one. Just got very little to ask about it. 0.290 counter bore over here. There's 8 of them. And are they rectangular or polar coordinate? So the holes, okay, let's see. Is it rectangular or polar? Really? Kind of looks that way. You got a diameter. And we've got an angle to locate that one. It's pointing at this one. There's 8 of them. The magic answer book, I think, missed that one pretty bad. Yeah. Wow. I don't know how in the world they thought that was rectangular. Because it's definitely on a radius and an angle. Okay, how many features are 8, and why is there a feature control frame? It's kind of these questions here, and and the author's answers are just like,
He'd be looking one company, didn't
yeah. It's kind of like me saying, Andrew, what's your first name? Why is the same feature control frame for the hole and counter bore? The positional tolerance for the hole and the counter bore are the same. That's his answer. Well, okay. It just kind of answered itself. Okay. So, anyway, apparently, these are not as controlled. You know, it's 15 thousandths, and whatever kind of screw or attachments going in here, fasteners going in here, 15 thousandths must work for that particular type of fastener to have it the same. We don't need tighter control on the pilot. So, all right, 446. Moving ahead. Good old simple part. The femoral A and P saw guide standard. Whole bunch of questions though. Okay, so on the half-inch dimension, give the location dimension from datum B and the location application relative to datum C. So it's located, let's see, the feature is located 0.672, am I looking at the right one? Yeah, 0.672 basic, okay, from B, all right, and then on center plane for C, there's no basic dimension, and C is datum feature control is placed at the opposite end of the arrowhead, so it means we're to consider this measurement here, and it would be a center plane type of datum for position. Okay, and then at max material condition. Okay. All right. Explain the meaning of the information in the feature control frame. Okay. The half-inch diameter must be a true position within 14 thousandths diameter tolerance zone at max material condition. Related to A, B, and C at max material condition, or max material boundary, excuse me. C, provide the positional tolerance and virtual condition. Uh-oh. So, 0.505. We look down here, it's a 3-place decimal, plus or minus 5 thousandths. So, at 505, the position tolerance would be 24 thousandths, 0.024. Okay. And the virtual condition would be 0.481. And then at the half-inch, or 0.500 produced size, your position tolerance would be 0.19. Your virtual condition would be 0.481. Your produced size at 0.495, your position tolerance would be 14 thousandths. Okay, hole at its smallest. Your virtual condition is 0.481.